Hello there and welcome to the series of videos going through the content of A-Level Further Maths. Here we're looking at how we will multiply matrices so we can answer questions from exercise 6b. Now, as I said in the previous video, multiplying matrices is actually much different to just multiplying the two cells how you would expect it to be. It's much more difficult. It's quite an unnatural way of doing it, and you'll have to be storing lots of numbers inside your head and summing them up afterwards, but as soon as you get a little bit of practice at this, hopefully you'll find it quite easy. Now, we can only multiply certain matrices with other matrices, and the way you can check how a matrix will multiply together is by making sure that the number of columns in the first matrix matches up with the number of rows in the first matrix. And your answer will be the number of rows that are in the first matrix times by the number of columns in the second matrix, and that will be the dimension of your answer. Now, this may look all hypothetical to start with. We'll go through a question and we'll see where this all links in. But basically, the number of columns in the first matrix must match up to the number of rows in the second matrix. And you will also see that if you were to attempt this multiplication without these two numbers being equal, you would run into some difficulties. So basically you would just stop if you're running into these sort of difficulties. Now let's have a look at how we would multiply these two matrices. Let's first do a little check that we can multiply these matrices together. Now this matrix here has 2 rows and 2 columns, so it's 2 by 2. And this matrix here has 2 rows and 1 column. So this is a 2 by 1 matrix. So given that this number here matches up with this number here, we are good to go on the multiplication. And our answer is going to look like a 2 by 1 matrix. Now this will all become very natural once you've had lots of practice at it, and you won't really need to think about the dimensions and the dimension of the answer because you'll be good at just multiplying the matrices together. Now let's see how we do it. Now, it would be great if it was just a case of 1 times minus 3, finish there, 3 times 2, finish there. Unfortunately, it doesn't work like that. The reason that we need the number of columns in this matrix to match up with the number of rows in this matrix is because that's how we're going to multiply. We're going to go multiplying red by red and then adding that on to blue times blue. So we're going to go along the rows in the first matrix and down the columns in the second matrix. So along in the first one, down in the second one. And then we're going to do both of those calculations, red times red and blue times blue, and add your answers together. So it's going to be 1 times minus 3, add minus 2 times 2, calculate these values. That will give us a minus 3 and a minus 4, so that top one will be minus 7. And then that will lead us to the value of this cell. And if we want to go down to work out the value of this cell, the second cell in the answer matrix, then we go with the second row in the first matrix and the only column that we have in the second matrix. So we multiply going along in the first one and down in the second one. So 3 times minus 3 and 4 times 2, and we add those results together. So first of all, we're going to get minus 7 for the first top cell, and then for the last one, we're going to get minus 9 add 8, which is minus 1. So our answer there is minus 7 minus 1. And that's how we multiply matrices together. We work along horizontally in the first matrix, and then we work vertically in the second matrix. And you can see that the reason that we need to have the number of columns in the first matrix match up with the number of rows in the second matrix, here they're both 2, because if we were to have a third value down here, there would be nothing for this 7 to multiply by in the first matrix, and vice versa. If there was a 7 here, there'd be nothing for the 7 to multiply with down there. So that's how you would run into some difficulties. Alright, let's have a go at another couple of questions here. Let's work out A times B and then work out and see if that's the same as B times A. See if it has that commutative property. So, A times B, let's first check that we can multiply these two matrices together. The number of columns matches up with the number of rows in the second matrix. Great. So that's going to work. If we go along and down, we get the same number of cells going along and down from the first matrix to the second matrix. And our answer there is going to be a 2 by 2 because that's the other dimensions that we have left. So, multiplying A and B together, remember we're going horizontally in the first matrix, vertically in the second matrix. Pause the video if you'd like to have a go without me giving you the answer straight away. So, the first thing we do is we're going to go along in the first one and vertically down in the second one, multiplying as we go along. So it's -1 times 4, add 0 times 0. And you might want to make a note of that just underneath as your calculations. So that's going to give us the answer to the top left-hand cell. Let's now look at the top right-hand cell. Now what we want, reading it correctly, we want the top row here and the right-hand column here. That's why we call it the top right. So looking at the cells that are now going vertically down in the second column here, -1 times 1, 0 times -2 will give us the answer to this top right-hand cell here. If we want the bottom left-hand cell, we're going to go for bottom and left. So it's going to go 2 and 3 times by 4 and 0, so 2 times 4, and then add that on to 3 times 0. And then for the bottom right-hand cell, it's going to be bottom and then right-hand side. So this is going to give us 2 times 1, add 3 times -2. Calculate all of those integer values. And we get our answer. We get -4, -1, 8, -4 as our answer to multiplying A by B. Okay, let's now have a go at multiplying these two matrices the other way and see what happens. Now here we're going to have a 2 by 2 multiplying by another 2 by 2, so we're going to get the same answer as before, or the same dimension as before rather, not necessarily the same answer. And this time we're going to go work horizontally on the first matrix and vertically in the second matrix. Pause the video and have a go if you don't want me to just give you the answer. So it's going to be 4 times 1 and then -1 times 2, and we'll add those two together. 4 times -1, 1 times 2. Looking at the top right, we're looking for the top row on the first one, the right hand column on the second one, so 4 times 0, and then moving across and down, 1 times 3 in the second cell, in the second calculation. Looking at the bottom left hand one now, we want the bottom row on the first matrix and the left hand column on the second matrix, so it's 0 times -1 and -2 times 2, going across and down. The next one here for the bottom right is going to be the bottom row and the right hand column, so lower going across and down. It's 0 times 0, add -2 times 3, and then do your calculations and work out the answer, and it's -2, 3, -4, 6. And just notice here how our answers to our matrix multiplications here are not the same. So therefore, what we could effectively say is that AB, in this case, is not necessarily the same as BA. So when you reverse the multiplication, you don't always get the same answer. In fact, we've done this with square matrices. If you were to do it with non-square matrices, you would actually get, if possible, to multiply these two matrices together, you would get matrices of different sizes as well. Okay, so this means that multiplication does matter, and you can't reverse the order of multiplication to suit your needs. Okay. Let's now have a look at where we can multiply matrices and how we spot when we can't multiply matrices together. So what the question is we've got three matrices here and we're asked to determine AB, BC, CA and BCA. So for question 1, calculating AB, we've effectively got a 1 by 3 matrix here and a 1 by 2 matrix here. And notice here, if we were going along and multiplying along the cells in the first matrix, we'd need 3 values going down so that we've got 3 things to match up with the 3 cells in this matrix here. We need 1, 2, 3 going down. We haven't got that. We've only got one row, so we can't multiply these two matrices together. So we just say that doing this is impossible. Let's have a look at the second question then. The second question is B times C. Now we can see here we're going 2 along in this matrix here, and we need to go 2 down. So that's how we can tell that we can multiply our matrices together. Our answer here is going to now be a 1 by 1 matrix, or effectively just a number. So remember, we go to the right in the first matrix and down in the second matrix. So this is going to be 3 times 4. Add minus 2 times 5, and you can do this in your head. You don't necessarily need to write down all these workings underneath. 3 times 4 is 12, add minus 10, 12 add minus 10 is 2. So you get just a matrix of a single element of 2. Okay, the next question on that list was times C by A. Now we can't do A times C to flip it around because that's going to give us a different answer. So we're going to need to do it in the order that it's given to us, C times A. Now in this matrix here, we're only going 1 across in this matrix. Here, remember, you always go across in the first matrix and you go down by, well, we've only got 1 value here, and those two match up, so we can multiply C and A together in that order. Our answer here is going to be a 2 by 3 matrix because those are the other 2 dimensions. So we work to the right in the first matrix and down in the second matrix, but given that we've only got 1 dimension in both of these different directions, it's just going to be 4 times 1 for the first cell. Second cell going across is going to be 4 times minus 1. The third cell going across is going to be 4 times minus 2. And then looking for the second row on this matrix, it's going to be 5 times 1, 5 times minus 1, and 5 times 2. Calculate all of these values, and we get our answer. 4 minus 4, 8, 5 minus 5, 10. Okay. Alright. The final question in this set was to times B, C, and A together. All 3 of them together at once. Now there are 2 different ways in which we can do this. We've seen previously that we can't rearrange the order that we multiply matrices in, but we can choose a different order to multiply them in as long as we keep them in the correct order. Now if we're doing BCA, we can either use our calculation for B times C first and then times that answer by A, or alternatively we could do C times A first in that order and then pre-multiply by B, putting the B matrix first to times it by the answer to CA. Okay, it's very similar to if you were doing 3 times 2 times 4. You could think of this as 3 times 2 times 4, or you could think of this as 3 times 2 times 4. Okay, it's exactly the same thing for numbers as matrices. So let's have a go at the first way of doing this, and generally in maths there's always more than one way of doing a calculation. So let's have a go at the first way of doing it. B times C, well we've already got that answer, that was 2, and then we'll times that by A, which is just 1 minus 1, 2. Now looking here, we're going to go across on this matrix, down on this matrix, and both of those have a 1 in there, have 1 dimension in that direction, so that's fine. So our answer is going to be 2 times 1 minus 1, 2, and you can think of this as just multiplying the matrix by 2, so you get 2 minus 2, 4. Let's try and do it the different way, so multiplying C and A first. That was our previous answer of 4 minus 4, 8, 5 minus 5, 10. And then we need to pre-multiply that by the matrix B. So make sure that B goes first, and then A goes second. So the CA matrix goes second. Now looking at this, we go along by 2, but we can also go down by 2, so the dimensions do match up here. So now let's work out the calculations here. It's going to be 3 times 4, add minus 2 times 5. So we can do most of these in our head, just storing numbers in your head and adding the results together afterwards. Or you can jot them down just in case you go wrong. So we're multiplying across in the first matrix, down in the second matrix. So this is going to give us the left-hand value. To get the middle value, we need to go to the middle column in the second matrix. So it's now 3 times minus 4, add minus 2 times 5. And for the right-hand cell, we're going to go to the right-hand column on the second matrix, 3 times 8, add minus 2 times 10. And that will give us our 3 answers. Now, the reason this doesn't have a second row on it is because this matrix here doesn't have a second row. If we could go down, then we need some more values here. Say, for example, a 7 and a 4, and that would give us a second row on this matrix here. But given that we don't have a second row. Okay, so we calculate all of these values, and we come up with our answer, 2 minus 2, 4. And notice here how that was the same answer as when we did it, just multiplying in a different order. Alright then, so here is a question here where we're given matrix A and matrix B, and we're told that matrix B times A gives us the 0 matrix. Calculate AB in terms of A. So first of all, we should probably work out what BA gives us. So when we multiply B by A, now we can multiply B by A because we're going to go along by 2 and we go down by 2 in the second matrix, so the matrices do match up in terms of columns and rows. And now let's multiply them together. It's going to be B times minus 1 and 2 times A, and we'll add those results together. So we're going to get minus B, add 2A. And it says given in the question that B times A is going to be 0. So therefore we know that minus B add 2A is 0, so therefore 2A is equal to B. So now we can look at calculating AB in terms of A only. So we're going to replace B with 2A in the matrix B. So now we need to calculate AB, so we're going to replace the B with the value 2A. Notice here how we're going 1 across in this first matrix, 1 down in the second matrix, so those two dimensions do match up. It's always across and then down. Now, let's have a go at multiplying these two matrices together. So we're going to go across and down, but given there's only one dimension in both directions, it's just a simple multiplication. So that's minus 1 times B, and for the top right-hand cell, it's minus 1 times 2. Now for the second row, we go down a cell in the first matrix, and now we start to go across in the second matrix. It's A times B and A times 2. So calculate these values here, and we get minus B, minus 2A, B, and 2A. But it says only in terms of A, so if it says anywhere in terms of A, that means our answer can only have the letter A in it. It can have numbers in it, but it can only have the letter A. So replace B with the letter A, or the letter 2A, because that's what it equals, and we get minus 2A, minus 2 stays the same. We're going to get 2A squared from the B turning into a 2A, and the last cell we're going to just keep it as 2A. So that's our answer to this question here, where we've calculated the value of AB. So a very good question to ask is, why do we multiply matrices like this? Now, You'll see in future videos that we can clearly link matrices and systems of equations together, so it may be useful to come back and see this clip once you've looked a few videos ahead. But let's just describe it. Let's say we've got an equation and it says u equals 3x plus 7y and v equals minus 2x plus 11y, just two random equations there. And then we've got another two set of equations. This is effectively matrix 1, this is effectively matrix 2, and this time it's p in terms of the letters u and v. So p here is equal to 13u, so that's 13 lots of all of this, minus 20v, so that's minus 20 lots of all of this. And then q is equal to 2u, so that's 2 lots of all of this, plus 6 lots of all of this. Now, how can we combine these two systems of equations together to give us p and q in terms of x and y? Well, one way of doing it is to just substitute in the value for u as our expression for u and the substitution for v as our substitution for v. So you can see here how we've done this. We've substituted u into both of the two equations like this. We've put 3x plus 7 into both of the positions for u. And we've done the same thing for v, where we've substituted in minus 2x plus 11y into both of the two positions for v. Multiply out your brackets, and you get this very ugly looking answer to what p and q are in terms of x and y. Now, what mathematicians a long time ago were looking at is there a shorter way of doing this substitution? And what they saw is that if you can represent your two matrices, your two systems of equations with a matrix, you can see here it's 13 minus 20, 2 and 6, and then multiply that matrix with a 3, 7, minus 2, 11, just like we've got this matrix here, we're going to get P and Q. P is going to be the top row, Q is going to be the second row in terms of X and Y. And if we were to now multiply these matrices together, and work out the answer, we get exactly the same as what we got in the substitution method. So P is equal to 79x minus 129y, and Q is equal to minus 6x plus 80y. Okay, so that is the reason why we multiply matrices in this way. They saw that this method here was a lot quicker, so they've stuck with it ever since. Alright, you don't need to know that bit though. All you need to know is what we were doing before and how to multiply these matrices together. We'll look at how we divide by matrices in a few videos' time. Have a go at these questions of timesing matrices together. Alright then, so let's have a go at this question here then. So just looking first, we can go along by 2 and down by 2 in the second matrix, so these two matrices can be multiplied together. Let's just open up our matrix and start multiplying. So we're going along in the first matrix and down in the second matrix. So it's minus 1 times 1 is minus 1. Add minus 2 times 1, that will give us a total of minus 3. So you don't need to do all of the calculations going through. If you can do it in your head, great, do it in your head. Now, keeping with this top row, I'm going to continue going across, and now I'm going to go down the second column here. So minus 1 times 0, that's 0. Don't have to remember anything there. Add minus 2 times 1, that's just going to be minus 2. Keeping on the top row, we're going to look at the right-hand values now. Minus 1 times 1 is minus 1, and then that's just going to be a 0 there. It's quite handy when matrices have zeros in them, because you don't really need to do too much work. You can kind of ignore the cells where they multiply by a 0. Right, now we're going to look on the second row now, and we're going to look at multiplying the 0 and the 3 by each of these columns here now. So 0 times 1, that's 0, don't have to remember that. 3 times 1 is 3. 0 times 0 is 0, 3 times 1 is 3. 0 times 1 is 0, 3 times 0 is also 0. So that's the final answer there. So you don't have to do all the calculations down the page like we did in the video just. You can do most of the calculation work in your head. Let's have a look now at, let's rule that off there, part A of question 5 here. The question is to multiply 2, 1 by 3, 1 minus 1, 2. Now looking across in this matrix here, I can only go 1 across, but I'm going to be going 2 down. So I cannot multiply these two matrices together. Question B is to multiply 2, 1 by C, which is minus 3 minus 2. Now you don't put a comma in between the matrices like I've done here. That was a mistake. So here we're going to go 1 across and 1 down. So that's going to match up, so that's great. So we can multiply these matrices together. So looking at the first value here, I'm going to go 1 across but only 1 down, so this isn't going to be too difficult. 2 times minus 3 is minus 6. Going across to the top right now, 2 times minus 2 is minus 4. Going down onto the second row now, 1 times minus 3 is minus 3. 1 times minus 2 is minus 2. So that's the answer to part B. The answer to part C here, when we multiply B by C, now we're going to be going 2 across in this matrix here, but only one possible dimension for going down. So this matrix here does not have an answer to it. We cannot multiply B and C together. Alright then, so that's all to it. You will absolutely need loads of practice at this, and loads of practice will make you really confident and more accurate and quicker at this as well. So quickness and accuracy here is going to be important for what we're going to do later on. So pause the video and have a go at lots of practice from exercise 6b. Don't take this exercise quickly, take it nice and slowly, work through all of the problems, ask your teacher for help if you need any, and persevere through those difficult questions. Thanks very much for watching.